Hey you guys, here's that little recap of last week. I'm going to break this up into little 5-minute chunks and just kind of release them to you guys. The quiz I have for tonight is based on just kind of solving trig, just doing triangles and getting values and seeing if you can do that via the online tools that you have. But that's just a kind of square one type of thing, and it'll give me a sense of where you guys are at. Not a huge amount of points, but it is a quiz, so do your best. Here's where we left off. We had a series, or we had the two triangles that we kind of built everything from, the 30, 60, 90, 45, 45, 90, and they had these sides. And at some point we talked about breaking them down into something called a unit size. But just for now, let me use those triangles again to tell you, no matter what size you make those triangles, if you go to a 30-degree, 60-degree angle, the ratio of the sides in a particular order is consistent no matter how big you make the triangle. Same with 45, 45, 90. It's the idea of similar triangles. You make them grow, the side ratios stay the same. So when I do sine of 30, for instance, I'm just going to evaluate these. So this would be something, these would be evaluating trig functions. And it happens so often as you go along in mathematics that it kind of has to be second nature after a while. So if somebody says sine of 30, you're instantly going opposite over hypotenuse. If you're using triangles like I did for so long, you're just going 1 over 2. So you instantly go, all right, 1/2. And then you get to cosine of 30, you're going, all right, it's that other one. So it's the adjacent over the hypotenuse, square root of 3 over 2. So you do these real quick calculations in your head, or you memorize them. Some people go that route. Tangent of 30 is the opposite over the adjacent, so it's 1 over the square root of 3. Those sides are, 1 over the, if you do tangent of 30, 1 over the square root of 3. We'll talk about rationalizing and all that stuff later. Then cosecant, secant, and cotangent, respectively, are just the reciprocals of those to the left of them. And so these are then the reciprocals. So we really only do sine, cosine, and tangent, and then if you need secant, cosecant, and cotangent, you just do the reciprocals of them. That's how I approach it. Get the original, then I flip it over. I do what's called the reciprocal function. Same thing for square root of the 45, 45, 90. If I say sine of 45 degrees, from either 45-degree angle, you're thinking opposite over hypotenuse, so it's 1 over the square root of 2. We're going to talk about equivalent forms here in a minute. Cosine, adjacent over hypotenuse, so it's 1 over the square root of 2 as well, so they're equal, but they measure different things, but they happen to be the same. And then tangent is 1 over 1. Which is just 1. Now when you do the reciprocals on the other side, same thing as before, just flip it over, square root of 2 over 1, and square root of 2 over 1. I'm not writing the over 1. You guys know that doesn't affect the value. And then the cotangent at 45 is also just 1. Those are the basic values using the triangles. Well, the other tool that we can put to use is the unit circle. And the unit circle is a way of kind of memorizing these. What we do is we squish these triangles down to what's called a unit size. Mentioned that last class as well. But the unit size is the hypotenuse. If I make it 1, then the other sides change accordingly. So I'm going to do this in, something green or something like that. So I do 1 over here. Then the leg below here is a half of that. That's the relationship between the hypotenuse and the short leg. It's always a half. And then finally, the side next to it, not the half side, but the other a little bit larger one, I just cut that in half. So instead of square root of 3, it's square root of 3 over 2. Everything got divided by 2, going from the triangle on the left to the one on the right. It's called the unit triangle. 30, 60, 90 triangle specifically, because we still have our 30, we still have our 60. So it's the unit 30, 60, 90. Then you can do that with the 45, 45, 90 as well. If you put in something that's a little bit smaller, shrink it down, that's 1. If you realize to achieve that, I had to divide by the square root of 2 on all sides. And what that does is 1 there, but on the legs it's 1 over the square root of 2 and 1 over the square root of 2. So that's just a smaller version of it. It doesn't change the answers you get for the values down below. If you want to go ahead and try a side here and there, you realize that the ratio of sides, even in that smaller triangle, works out the same way. For instance, just as a quick one, if I did the cosine of 45 degrees, it'd be 1 over the square root of 2 over 1, and 1 over the square root of 2 over 1 is still 1 over the square root of 2, so it's not changing that value at all. Okay, so that's the unit part. Now I'm going to bring up the unit circle and just give you an idea how to wedge those triangles in there, and we'll run it from there in the next video. This is it. So this unit circle, what it does is allows me to lay those two triangles Here's a 30, 60, 90, for instance, kind of wedged in here, 30, 60, and there's that right-hand corner. But what we have is, inside there, what I can do is think of those sides of the unit triangle that I made for the 30, 60 right before we left. They all had a hypotenuse of 1. I can do the same with laying on its other side, but this is called a unit circle because the length from the center to any edge is 1 unit long. That's why that unit triangle fits in it. You can go to any side on here. The radius out there is 1, radius is 1, radius is 1. So that's the idea. Definition of a circle is, it's the kind of collection of points equidistant from a single point. There's how that all fits. Now, this is a tool to help you remember 30, 60, 90, and also just pick up on some other neat things about triangles in general. I'm going to put the other 30, 60, 90 in here, just for reference, to give you a place to see where this all unfolds. And I'm going to do this in orange, so watch those labels. Now, the 1 length is the hypotenuse, but I have the 60 in the corner now, and so if I do big 60 in orange, right here you can kind of see it's that whole corner 60, the 30 is up here, and the short leg and long leg kind of traded places when you lay it like that. But that's it. You can lay those 30, 60, 90s in there all you want. Now if I just keep that up, if I do orange triangles as kind of the tall side-facing version of the 30, 60, 90, there's one, and the red ones are always my 30, 60, 90 kind of on their side, like this. Then what you see is the triangles. I just lay them here and there all over the place. I'll keep going, but keep an eye on that pattern. I'm going to use the side lengths of that unit 30, 60, 90 to actually come up with an XY coordinate point, like moving around left and right and up and down. So let's finish this off. Orange triangles, the kind of the tall ones laying on their sides. Notice there's actually these dotted lines in here that indicate the 30 and 60 degree angles as well as 45 degree angles. So the unit circle is built on 45, 30, and 60 degree angles, 90s as well, but I'm going to do some red. So just watch as I fill these triangles in here. And even this itself is a good exercise in just seeing how this pattern works out. Now, what I'm going to do, if I go back to the original red triangle that I had over here and I label, I'm going to kind of erase some numbers so you can see a little bit better, so you can clean this up. You know it's a 30, 60, 90. You know the hypotenuse is 1. Okay, I'm going to delete some of this stuff. Beautiful. The side lengths, other than that, are like half. Remember this little short side is half of the hypotenuse? It's on its side. Maybe it's hard for you to see that, but look at that half right there. 1, and do you remember the long side here? Down on the bottom, I'm kind of tracing it right now. That's square root of 3 over 2. Circle that. Because I know those side lengths on top of there, the unit circle is actually imposed on like the grid. If I wanted to put it on an actual like XY coordinate grid, it would only fit in between left 1, up 1, down 1. Maybe I should I'll put some black big lines on here, but it'd be like your grids all out here. I'm going to get rid of these in a minute. But it's right in your normal grid. It's just a really, really, really tiny, this would be like 1 tall and 1 to the left and 1 to the right, and isn't that crazy? It's just squeezed in there. But what we do is we use that to help us memorize those 30, 60, 90, and 45, 45, 90 ratios. Okay. Now what I'm going to do in the next video is we're going to talk about how to put coordinates in here. So this is the first one I'm going to label, and then I'm going to let you percolate on that for a second. But this is, since the way I've done this is I've gone to the right, square root of 3 over 2, here, and then I've gone up a half. You could actually label, because I know the lengths of that triangle, I could actually label that point, and that's exactly what I'm doing, I'm labeling a point there. Square root of 3 over 2, because I went to the right, that's my x, and then my height I went up is 1/2. Okay? What ends up happening is that because we know those sides so well, we like to label the coordinates on there, and we find out they have deeper meaning here a little bit later with respect to trig. But we go along and label all the points like, hey, and this, do you notice in the other triangle, the orange one, it would kind of trade places. You'd have a half here, square root of 3 over 2. So it's a half to the right, and then square root of 3 over 2 up. So they trade. Okay, that's enough for this one. Next.